We are finishing up section 5.4, which has been on indefinite integrals and, of course, also included definite integrals. And we're going to finish it up by looking at the net change theorem and an example. The net change theorem says that the integral of a rate of change is the net change. The integral of a rate of change is the net change. So pause for a minute to convince yourself that you understand what that means. Okay, so the function that we're taking the integral of is or represents a rate of change of something. So let's look at this one little example. If oil leaks from a tank at a rate of R of t, gallons per minute. So it's a function, they're not defining the function for us. We're just saying that R sub t, gallons per minute, this is a rate. So the oil is leaking from this tank at this rate. What does the integral of from 0 to 120 of R of t dt represent? So again, referring back to the net change theorem, the integral of a rate of change, so that's what we're doing here. We're taking the integral of a rate of change. This rate of change happens to be oil leakage per minute, gallons per minute. So it should result, after we take that integral, according to our net change theorem, it would result in a net change. So this oil leakage, taking the integral of the rate of leakage, represents how much oil leaked. So the net change in the oil leakage in gallons over this period of 120 minutes. Let's look at an example. Here we have a storage tank. It's storing water, and water is coming out from the bottom. So maybe somebody opened the faucet, or maybe there's a hole in the tank, but it is leaking at a rate. So we're given a rate of leakage, 200 minus 4t liters per minute. So 200 minus 4t liters per minute, that's our rate. And for time greater than or equal to 0, less than or equal to 50, so basically what that means is this model that we're given, this 200 minus 4t liters per minute, is really only accurate when we're looking at times between 0 and 50 minutes. That's really what that means. So we're being asked to find the amount of water that flows from the tank during the first 10 minutes. So the amount of water, so the net amount, the net change in the water in the storage tank. So again, the integral of a rate of change is the net change. We're trying to find the net change of the water. So if we take the integral of the rate that the water is flowing out of the tank, that should give us the amount of water that flows from the tank during those 10 minutes. So when we set it up, we're going to set up our definite integral from 0 to 10 minutes because we're only interested in that first 10 minutes. And so we need to find the antiderivative and then subtract to find the definite integral. So we have to find the antiderivative of 200 minus 4t. So the antiderivative is 200t minus 2t squared. And we're going to evaluate that between 0 and 10, which means we will find the value at 10. We'll find the value at 0. We'll subtract the 2. And we'll come out with 1,800 gallons. So then, of course, you should interpret that answer. You should write the answer as a sentence. 1,800 gallons of water flowed from the bottom of the storage tank in the first 10 minutes.